Today, I want to talk about one of the major category in data mining, which is about the classification. So in this topic, I want to divide today's video into two parts. The first part is going to be classification general introduction. Then we will look into the decision tree, which is our first classification algorithm I want to talk with you guys. So start with the classification. What is classification? Classification, usually used for prediction, are two forms of the data analysis that can be used to extract model. So we build up a model describing important data classes or to predict future data trends. So those are the major things that we want to do. So how can we do that? Basically, we want to learn from some existing cases. And based on those existing cases, we can describe important data classes, or we can use the model that we build to do the prediction. And that is the main idea about the classification. For example, bank try to loan money to people, but you don't loan to every single one of it. You can take a look of the credit history, age, income, etc. to build up a model, and we are able to label the customers as safe or risky. And of course, for those people who are safe, we want to loan them the money, probably even with lower interest rate. For those people who are risky, bank probably don't want to loan the money, don't allow the money, or they were going to charge them very high interests to compensate the risk. So that is one of the case that can easily describe what we use classification in our daily basis. We can guess a customer try to buy a new computer or not. Obviously, like Best Buy has a long list of their customers. And based on their transaction histories, based on a lot of different information, they can make a pretty good prediction that is this guy going to looking for some new computers or looking for some camera or anything, so that they can send them the coupons, or they can give them the most latest advertisements, and so that maybe we can lure them to come into the store and then purchase something. Analyze cancer data to predict whether or one have one of the cancers, or what is the best treatments for this kind of scenario if there are several choices. Usually we rely on doctors' judgments, and of course computer systems or the classification models can help the decisions of those kind of things. And therefore, these are some daily cases that we would be able to use classification. And of course, you can think about much more than these examples. So classification is a two-step process. Like I mentioned earlier, classification is try to learn things from the historical data, from the data that you have. So the first thing for classification trying to do is that it need to build up a model to extract the information out of it. And that is what we call a learning step. So classifies data based on the training set and the values or the labels in a classification attribute, and used to classify new data. So based on the existing data, and that's what we call the training data. And we want to use those training data to build a model that can be used for making a prediction. So after the model is made, now when we call the testing data or some unknown data comes in, we will be able to make our predictions based on the models that we have been built. So that is what we call a two-step process. Most generally, the classification algorithms follow these two steps. Of course, there are some exceptions, and we will talk about that when we comes to the algorithm or the different classification algorithms descriptions. So here is the idea. Based on the data that we have seen over here, and of course we need to understand the data first. This is about college information. So we have 1, 2, 3, 4, 5, 6 professors. We have the name of the professor. We have their rank of the professor. So rank is divided into 3 different kind of categories, starting with assistant professor goes to associate professor goes to professor. We also have the information regarding to how many years that they have served in this university. Then we have one last attribute called the label. So indicating that this is something, say we are targeted about. Based on the rank, year, and maybe name, I don't know about that, but you can try to make a prediction, build out a model to see if this professor is tenured or not. And basically that is like the idea regarding to this data set over here. Based on the training data set that we have, we want to use some classification algorithm. And here is the important key things regarding to this class. We will introduce multiple classification algorithms. Each one of that will use the training data set to build up a model with different ways. So once we have the model, we will be able to use the model. Some of the models build what we call a white box classification. So in that category, we can easily understand the model. So here is an example. If rank equal to professor or year greater than 6 years, then tenure equals to yes. So we would be able to build up a rule-based information, just like this one. And it's possible to have multiple rules that we can use for making a prediction. So no matter what, this is what we call the learning step. Build up a model, either some white box classification that we can understand, or black box classification. That means they build up some mathematical complicated things and that are not able to be translated in English or in human knowledge. But sometimes those kind of things can make very, very good predictions because some crazy mathematical models are behind that. So this is the first step. We build up some models, and then we would use the model construction, describe a set of predetermined classes, and then each tuple sample is assumed to belong to a prediction class as determined the class label attribute. Then the set of tuples used to model construction is called a training set. Like we see earlier in the previous slide, the model is represented as a classification rules, decision tree, or some mathematical formula, multiple things. And once we have that model, we can build up a classifier. So now when a testing data set comes in, you can see that those 4 new professors that we have not seen previously, we can use those information go through the classification and then make the predictions out of it. So you can see that if we have another professor, Jeff, who is a professor, is only served here for 4 years. Is this person tenured or not? And we can basically use that model that we have been built to make the prediction. And one thing you can see that even though this is the testing data set, one interesting thing that you make curious is that didn't you say that you don't know whether or not they are tenured? In this case, we do know they are tenured or not, but we will try to hide this information so that when we put our testing data into the classifier, we only put first, second, and third column into it, and then the classifier tells us that are they tenured or not. So the classifier will generate a result, and we can put that side by side to evaluate how accurate does the classifier be, so that we would be able to tell if this is a good model or not. So that is the idea about the prediction step. So the prediction step, we want to estimate the accuracy, and that's exactly what I've mentioned. We do have the answer, but we pretend we don't know, so that the classifier or the model will use the testing data without the label and make the prediction about the label. So we would be able to look the results side by side, and therefore we can evaluate the accuracy of the model. The known label of the test sample is compared with the classified result from the model, so that we will be able to see. The accuracy rate is the percentage of test set samples that are correctly classified by the model, so we can know how accurately does the model can make the prediction. There's sometimes have some problem called overfitting problem, is that the model is totally designed for some special scenarios, and now when the new data comes in, it may not be able to predict well. However, when it's tested on the data that you already have, they have perfectly performed, maybe like 98% accurate. But when it comes to the real data set, it's dropped down to like 60%, 70%. And in that case, that's what we sometimes call an overfitting problem. So when we try to design the training process, we also need to be careful about the overfitting problem. So there are many important things that will affect the accuracy about the classification model, including data cleaning. So the data need to be cleaned. Like we said, data preprocessing is one of the most important steps regarding to the classification. We need to make sure the data is clean enough. There's no noise, there's no outliers, and there's no missing values, so that the classifiers can do the best performance out of it. It can also be some relevance analysis, so remove some irrelevant or redundant attributes, such as name in our previous example. Usually, or logically, name should not be a factor in the tenure or not system. So those are something that you want to check. Maybe they are relevant, maybe they are not. We need to select the few features. Sometimes that the classification problem is facing a data set with more than 100 attributes. Obviously, not all of them are important. How would you rank them? Would you remove some of the attributes is always an important issue regarding to the classification problems. Finally, data transformation. We need to generalize and or normalize the data so that each attributes have similar weights, or if you want to add the weight to the attributes, you also need to transform that into a manner that they can be easily achieved. So there's a lot of different things that will affect the prediction accuracies regarding to the classification algorithms, and these are the things that you need to pay attention to. So because the class label of each training tuple is provided, like we see, the professors are tenured or not. That is what we call a class label. And therefore, in order to build up a model based on a class label, that is what we call a supervised learning, because we are supervised, knowing the results already. Compare with that, if you don't have a label, and you want to work with the data that's without a label, then that is transforming the problem into what we call unsupervised learning. So what that's trying to do is simply putting similar, say, professors all together, and then we try to look into the similarities, additional information for each cluster. So that is the main difference between supervised learning and unsupervised learning, is the label that decide which type of learning that we are looking at. So here is another examples that you can see, saying that we have the age with different categories over here, income, whether or not the person is a student. We also have their credit rating. So saying that we use these 4 attributes and we want to make the prediction of this person has a computer, buys a computers or not. So obviously when we do that, we treat buy computer as the label. And if we build up a classification model based on this is obviously a supervised learning. So in other words, if we try to get rid of the last column, use only 4 attributes, what we would perform is called clustering, and that is why we try to cluster them similar things together. Maybe a group of young people, low income students that are being grouped into one cluster, and then we also may have some older age with high incomes with great credit ratings that's going to be form another cluster. So when we do that, we can think about different strategies to work with different clusters, and that is what we call unsupervised learning.